day, everyone. We are here to discuss the findings in the experiment entitled Permanganate Titration of Hydrogen Peroxide. Hydrogen peroxide is commercially used in different applications such as commercial bleaching processes, wastewater treatment, rocket propulsion, and hair bleaching agents. It is also known for its anti-infective, antiseptic, and cleansing agent property, which varies based on the concentration solution. It is important to know the actual concentration of a solution of hydrogen peroxide as its effectiveness can decrease with smaller concentrations and can be hazardous at higher ones. Following the principles of redox reaction, the number of electrons lost by the species being oxidized is always equal to the number of electrons gained by the species being reduced. On the other hand, titration is a method of volumetric analysis wherein volume measurements are used to obtain concentration of an unknown solution. Redox titration can be used for an analyte that can be oxidized or reduced. In the reaction being studied in this experiment, solution of hydrogen peroxide will be titrated using potassium permanganate in order to determine the concentration of the commercialized hydrogen peroxide. Throughout the experiment, students will be able to familiarize with the different steps of standardization of prepared potassium permanganate solution and determine its concentration as well as the calculating the percentage of hydrogen peroxide present in the market.
Materials and methods. For the collection and preparation of materials, the glasswares and reagents used in this experiment were gathered from the chemistry laboratory. The commercial hydrogen peroxide solution and potassium permanganate solution was prepared by the instructor. Standardizing potassium permanganate with sodium oxalate. The potassium permanganate solution was standardized using the standard procedure before titration. And approximately 0.10 grams of sodium oxalate was weighed and placed into a 250 ml beaker. It was then dissolved with 50 ml of water and acidified with 10 ml of 3 molar sulfuric acid, which is mixed with a small amount of manganese sulfate. The solution was then heated to near boiling before titrating. After heating the solution, it was titrated with a prepared permanganate solution while constantly stirring until the solution becomes pale pink, which indicates that the endpoint was reached. Titrating a commercial hydrogen peroxide solution. For the second set of experiment, 5 ml of the commercial hydrogen peroxide solution was transferred into a clean 250 ml Erlenmeyer flask using a burette. The commercial hydrogen peroxide solution was then diluted with 50 ml distilled water, and then 10 ml of 3 molar sulfuric acid was added. In preparation for the titration, the burette was filled with the standardized permanganate solution, and the initial reading was recorded. The peroxide solution was then titrated while it is constantly being stirred by gently swirling the flask until the persistence of the permanganate color, which indicates that the peroxide solution was gone. The procedure was then replicated 3 times, and the final reading of the burette in each replicate was recorded for further use in determining the percentage of hydrogen peroxide in the solution.
Data management. The molarity of potassium permanganate as well as the percent concentration of hydrogen peroxide was determined following the formulas respectively.
For the results and discussion, first is the standardization of potassium permanganate with sodium oxalate. The solution of potassium permanganate cannot be prepared accurately through fixed concentration. Thus, the solution was titrated with the known mass of solid sodium oxalate and the resulting data is given in the table 1. The average mass of the 3 samples of sodium oxalate was calculated prior to the computation of the molarity. The standardization of potassium permanganate was done 3 times and the results are 15.60 ml, 15.50 ml, and 15.55 ml from standardization 1 to 3 respectively. The average volume of the delivered potassium permanganate was then calculated and the resulting data is 15.55 ml. Using the average mass of the sodium oxalate and the average volume of the delivered potassium permanganate, the molarity of the solution was obtained and known to be 0.0202 molar. The acquired molarity will then be used in the next part of the experiment. Next is the titration of the commercial hydrogen peroxide solution. And as the standardized potassium permanganate solution was added, it reacts with the H2O2 to produce colorless manganese ion, and thus from the blurred solution it becomes clear. When all of the H2O2 was used up, the faint amount of potassium permanganate added will keep its color as the endpoint is reached, causing the solution to turn pale pink. Table 2 shows the gathered data during the titration of the hydrogen peroxide solution, such as the amount of the sample and the volume of the potassium permanganate that was delivered. In each replicate, the volume of the potassium permanganate delivered agreed within positive and negative 1, which indicates precision of the recorded data. The volume of the potassium permanganate delivered was 130.50 ml, 129 ml, and 128.55 ml from replicate 1, 2, and 3 respectively. The average volume of the delivered potassium permanganate was 129.35 ml. The average volume of the sample and the potassium permanganate delivered was then calculated, and with this, the percent H2O2 was calculated. Using the gathered data, the percent H2O2 was calculated, resulting in 2.89%. The theoretical percentage of the commercialized hydrogen peroxide used in the experiment is 3%. In order to determine the closeness of the claimed value to the experimental value, absolute error was calculated. The calculated absolute error in this experiment is 0.04%. Sources of error can be from the measurement of the solutions, calculation of the needed data, or from an instrumental error. Nevertheless, with the results obtained in this experiment, it can therefore be concluded that the claimed percentage value of the manufacturer is accurate since it is close to the actual value obtained.
In conclusion, using the concept of the redox reactions, students were able to analyze the chemical reaction that takes place in potassium permanganate when standardized with sodium oxalate, as well as calculate its unknown concentration using titration method. The students also become knowledgeable about the redox reactions between standardized potassium permanganate and hydrogen peroxide. Finally, students were able to determine the different concentrations and usage of hydrogen peroxide in calculating its actual percentage again by using titration method and compare it to the claimed value of the manufacturer. Additionally, proper application of analytical techniques such as accurate measurements and appropriate use of laboratory instruments help lessen the occurrence of errors in the experiment.